Okay, now I'm going to show you how to do an independent samples t-test using our class data set. All right. So if you recall, we saw just by looking at a bar chart that looked like people with a job spent more time studying than people without a job. But at that time, we didn't know how to test that. Okay, so now we're going to test it. So they're independent groups. So people with a job are not the same people as the people who had a job. So we can select analyze, compare means, independent samples t-test because they're independent, right? And we're going to put, do you have a job as our grouping variable? So that's the first thing you do. Now then we need to define our groups to tell SPSS what the numbers are for each. So in this case, the default, it just spits out 1 and 2, which works for us because we coded with a job and without a job as 1 and 2. I can't remember which way was which, but I know it's like that. So we just have to put those in there. If our values were 99 and 7, we'd have to put 99 and 7. So whatever our values were for our different groups, right? Then we hit continue. And now we wanted to select how many hours on average do you spend studying per week? Okay, we can right click to make sure we have the right one. Yep, study hours. All right. Then we really don't have to worry. All the default is SPSS already provides by default what we want. Now, before we hit OK, we're going to hypothesize that people with a job spend more time studying just based on those bar charts we saw. So that's a directional hypothesis. This means that if the mean of the people with a job is higher than those without a job, and it's statistically significant, that is, if the p-value is less than 0.05, then we can reject the null hypothesis. If it's the other way, we can't at all. So let's hit OK. All right, here is the output. Well, let's have a look. Let me get my pen out here. So we can have N for, do you have a job? This is no. 31 people did not have a job. 60 people did have a job. And we can see the mean for without a job is 7.23 and with a job is 10.37. So right there, we know that yes, as we already did, that those who have a job spend more time studying. So if this is statistically significant, then we can reject the null hypothesis. We also have our standard deviations right here, right? And the standard error of the mean. So let's go down to our test. So we're not going to pay attention to Levine's test for now in this course. We're just going to look at that top line. We see the t-value is negative 2.14. Degrees of freedom is 89. Now we're interested in the one-sided p because we hypothesized that what people with a job would report studying more than people without. So we look there and we see the one-sided p-value is 0.018, all right? 0.018 is less than 0.05, so therefore we can reject the null hypothesis and conclude that people with a job study more hours per week than people without a job, okay? In plain English, people with a job reported studying more or studied more per week than people without. Our formal statistical notation would just be, we could say people with a job studied more than people without, T, parentheses, degrees of freedom, which is 89. Equals, we don't need to put negative 2.14, but we can if we want. I'm just going to put 2.14, comma, P, and remember, we report P to 3 decimal places without a 0 in front of the decimal place because it cannot be greater than 1. So 0.018, okay? Then we should also report the D, Cohen's D, right? This is a measure of effect size, right? D equals, and again, D can be greater than 1, so we're going to include a 0 in front. Here's the point estimate is the D value, right? 0.47, I believe that was, although I wrote on 0.47. All right. Other things we have here. So if we scroll over, we have, let me clear these drawings out. We also have the mean difference here, 95% confidence interval around the differences, right? All right. So that's how you run an independent samples t-test.